Hello everybody, my name is Ben Weekly, and this is the second session in a series of boiler lessons that I'm putting out on YouTube for boiler operators. And the lessons are on low pressure boilers. So those people that want to upgrade their licensing, upgrade their knowledge of low pressure boilers, this is a good resource for you. Last week was session 1, and I had recommended during that time that you purchase a couple books to go along and supplement your learning process and help cover every last bit of low pressure boilers. What I go over in these lessons doesn't necessarily cover every last detail that's in these textbooks, but I try to touch on the most important. The first book I recommended was Low Pressure Boilers by American Technical Publishers. So if you haven't gotten that by now, by all means, go to your website, look up American Technical Publishers, and purchase this book. This is the 4th edition. Right now, currently, they have a 5th edition out. In addition to that, I'd recommend you get the supplemental aid. It's the Low Pressure Boiler Study Guide. This goes hand in hand with the textbook and has all kinds of supplemental information and questions that will reinforce your learning process with the textbook. Now, if you're a beginning boiler operator in Minnesota and you're looking to get a special license, this is the particular book that I would recommend for you. It's entitled Safe Boiler Operation Fundamentals, Special Engineer's Guide for the state of Minnesota. So if you're out there in Minnesota, you want to get a special license, this is the book to get, because it touches a lot on low pressure boilers, and it also touches somewhat on high pressure boilers, because in Minnesota with a special license, which is a beginning license into the field, you can operate low pressure or high pressure boilers up to 50 psi. Well, I always want to restate the fact that these boiler lessons that I'm giving are just given from a guy that's had about 30 years of boiler operation and about 25 years of giving boiler classes. And I don't consider myself a professional, and I don't consider myself someone who knows everything about boilers. In fact, I would go so far as to say nobody really knows everything about boilers. No one person knows it all. So if you're starting out, don't be discouraged. Get into your textbooks, listen to the people around you that understand the boiler operation, ask them questions, and then of course watch the video series, and hopefully we'll impart enough knowledge into you that you'll be interested in the field and that you can operate low pressure boilers in a safe manner. You know, this country is really tied in its history back to boilers in a lot of different ways. Down in Mississippi back in the 1850s, there were 2 brothers, and the one brother, his name was Sam. He was a pilot on a big steamship, one of the big paddle wheel steamships. And if you were a pilot in those days, you made pretty good money, and you could punch your own ticket, because you not only knew how to operate the boilers in the ship, but you also knew how to navigate the ship. Well, Sam was making good money, and his younger brother wanted to get in on this. Well, the only way to get in on it was to start at the very bottom as a mud clerk. And there you got room and board, and you worked 16 hours a day, and you got no pay. Well, Henry back then begged and pleaded with his brother Sam to give him a job as a mud clerk on the boat. So Sam did that. Well, Henry was all excited about it. this was a new adventure for him. He was just leaving home and wanted to stake out his own manhood, I guess. Anyway, before they could actually set out on the Mississippi River down in Louisiana, Sam got into an argument with the owner, and apparently was not happy with his employment, and he quit, and he went 30 miles up the Mississippi and found another owner that needed a pilot, and evidently thought he got himself a better deal. While Sam was there getting acquainted with his new steamship, he received word that the ship that Henry was on, the one that Sam was originally the pilot of, had taken off from port, headed up the Mississippi, and had a tremendous boiler explosion and sank and destroyed the vessel, and many people were injured, and Henry was severely injured. And so Sam was alarmed about this. He got on the first fastest steamer and headed down to see his brother Henry, who was in the hospital. When Sam got to the hospital, they told him, you better guard yourself, Sam, because you probably won't recognize your brother, and he's very near to death. So Sam, anxious to see his brother, rounded the corner into the room, and there he seen his brother in the bed, his emaciated body, his swollen face, scalded, severely wounded, and barely coherent. When he seen that, he sank to his knees. He couldn't believe it. And, well, to make this long story short, Henry died just over a week later, and they said in the papers it was probably for the best. But Sam and Henry's last name was Clemens, and Sam was Samuel Clemens. He's the fella that we know of as Mark Twain. It is no wonder that Mark Twain, based on this experience, was fascinated with steamships, paddle wheel boats, and the Mississippi River. Well, so much for the stories. Let's get right to work here. The first thing I want to talk about, and the first thing that I would come to mind when I talk about boilers, is the safety valve. Safety valves on low pressure boilers are rated at 15 PSI. They're rated at 15 PSI. That's as high as you can go pressure-wise with low pressure boilers. Now, safety valves are on steam boilers, and safety relief valves are on hot water boilers. So there's a little bit of a difference. They're both called safety because they save lives. Now, what do? Well, let's take a look at one. I have a safety valve here that I took off an old boiler. Here's the discharge port going out that relieves the steam pressure. This here is where it connects to the boiler. This kind of fat area around the middle of this is called the huddling chamber. We'll talk about that in a minute. There's the stamp. There's the label on it, and it'll have a national board label on it and an ASME label on it, and it will have the rating on it as to how much energy it can discharge. You can see the spring at the top. I've got this opened up, and you can see the tension and pressure spring that pushes down on the valve stem and holds it tight to the valve seat. On the side here is the tri-lever, and this is what you lift to test the valve and clean the valve periodically to keep it in good working condition and safe working conditions. Okay. Safety valves, first of all, where they connect to the boiler, between the valve and the boiler, they cannot have any kind of valve there. And they need to connect to the highest part of the steam side of the boiler itself. the discharge line has to be supported so that if it gets to rocking, it can't break the safety valve off. So it has to be supported. And normally there is no discharge valves. I mean, there's no valves on that discharge line. So that makes the valve itself very reliable. We can't take any chances of having anything accidentally shut off on a safety valve. The safety valves for steam boilers are rated in pounds of steam per hour, and on hot water boilers, the safety relief valves are rated in BTUs per hour. Safety relief valves are a little different in the way they operate. Safety relief valves on hot water boilers, as the boiler pressure nears the set pressure, it forces the valve open slowly and proportionately to the pressure that's being generated in the boiler. Safety valves on steam boilers are meant to jump open and discharge steam pressure quickly and drop the pressure in the boiler 2 to 4 psi, and then they're supposed to slam shut. That's how a safety valve on a steam boiler is supposed to operate. Remember I said safety valves are rated in pounds of steam per hour. Well, you say, what's a pound of steam? That seems like a mythical thing. Well, 1 pound of water, which is about 1 pint, boiled into steam is 1 pound of steam. So the safety valves and safety relief valves on boilers are calculated and put on the boiler so that their capacity will relieve all the energy that the burner can possibly put into the boiler. So if your safety valve is operating correctly, your boiler would never explode. How does safety valves operate? Remember I told you they jump open. Well, I got a sample homemade valve stem here, and I'll do a little demonstration with it. Let's say that this is a valve stem in the safety valve, and around the valve stem itself is a spring. We'll just pretend like my fingers are the spring. Well, anyway, this is a 3-inch safety valve. Remember we talked about, I showed you the huddling chamber. That area right there is meant to assist this valve stem to jump open. When this is down on the valve seat and the pressure goes beyond 15 psi, it pushes this up, and the steam pressure is pushing on this. And the minute it opens, the steam goes around the edge of this and pushes up on this extra ledge of metal around the edge of it. Now on this particular sample that I got, the bigger disc here is about 3.5 inches, and this is 3 inches. So this is roughly 1/4 of an inch around here. But that 1/4 of an inch just about doubles the pushing power of the steam. And that's why it will jump open, relieve 2 to 4 psi called blowback, and then snap shut. If it doesn't snap shut and hold shut, if it sits there and jumps up and down, that is a faulty valve. That's called chattering. It needs to get repaired or replaced. So the huddling chamber on a safety valve is meant to assist the valve stem to open up and jump open and relieve the pressure of the steam around it and push it out through the discharge line. Okay, one thing that you boiler operators out there need to be able to know is one simple formula, and that's how to calculate how much force is actually being pushed up on a given size valve. So this is a 3-inch valve. It's on a 3-inch valve seat, and the total force on a safety valve low pressure will be that total force and the pressure going against it. It has a formula. Total force would equal the pressure, which is 15 pounds, times the area of the valve stem. Now, to calculate the area, you take and multiply the diameter times the diameter, and then you multiply that figure by 0.7854. So on this one, it'd be 3 inches times 3 inches, which would be 9. You would take that times 0.7854 to get the area of this round disc. And then you would multiply that area times 15 psi. And on a 3-inch disc like this, you would roughly calculate that at about 105 to 106 psi total force. Now, if you added the 3.5 inch, that total force would jump up to about 140. And so that's why this valve stem would jump open and relieve the pressure inside the steam boiler. One thing we never want to do is tamper with a safety valve or safety relief valve. If they're not opening right, if they're not closing right, you never want to tap on them with a hammer to set that down and assist the valve. Never tamper with a safety valve. If they're not working right, then the best thing to do is call for service and get somebody in that is trained and certified to either service the valve and repair it or to replace it. With safety valves like this one on a steam boiler, they need to be tested once a month. And you test them by pulling open the tri-lever on the valve. And you hold it open for 5 to 10 seconds and allow the steam to clean the valve seat and the bottom of the valve stem so that there can be no way they can chemically weld themselves shut together. You do that when the boiler itself is about at 75% of the MAWP, which would be 15 pounds on a low pressure boiler. Many of you out there probably run boilers that would never get up to that 75 percentile on 15 psi. You might run boilers that operate 2 to 5 or maybe 4 to 7, something like that. So when I would test those valves, I'd hold them open maybe just a little bit longer, and I would pop them open when your pressure is at its highest amount. So that's my recommendations on that. On hot water boilers, you would wait until the burner's off. I like to do hot water safety relief valves when the pressure is lowest on the boiler. And I would hold them open for 5 to 10 seconds and let them go shut. If you don't test them once a month, you should test them at least once every quarter. In Minnesota, I believe on a lot of the low pressure boilers, the recommendation now is to test those safety relief valves once every quarter. Well, so much for safety valves. Safety valve is a fitting that attaches directly to the boiler, and it's the most important fitting, safety fitting on a boiler, bar none. Now let's talk about steam gauges. Here's a steam pressure gauge that I took off an old steam boiler. This thing was built back in the early 1960s, this boiler, so this is what they would look like. This is a steam pressure gauge. They have to read 1.5 to 2 times the MAWP. So the maximum allowable working pressure on a low pressure boiler here is 15 psi. So you can see the 15 is right up here, and it goes all the way to 30, I guess, goes the other way, goes all the way to 30 psi. And the reason for that is if you came in and the gauge stopped at 15 psi and a needle was sitting there, you wouldn't know if it was 15 psi or if it was well beyond that pressure. So by having a gauge that goes well beyond 15 psi, it can give the operator an idea of how much overpressurized the boiler has gotten. So 1.5 to 2 times the MAWP is the standard for steam pressure gauges on low pressure. The other thing, if your steam gauge is mounted down low and you got a boiler that's say 16 to 18 feet high, the piping that comes down to that steam gauge so that you can easily read it has water in it, and that water adds additional pressure, 0.433 pounds per foot of additional pressure. So you got to take that into consideration as well. On the bottom of the steam gauge will be this here pigtail or siphon, they call it, and there will be water or condensate in that, intentionally placed there so that when the steam comes up and puts pressure, it forces the water up, and the water protects the internal working mechanisms of the steam gauge. And one of the most important things that it's protecting is an internal part called the bourbon tube. The bourbon tube on a steam gauge was invented by a guy by the name of Bourbon. Well, that wasn't such a hard guess. Here I have a steam gauge, and I'll turn it around and show you what a bourbon tube looks like. You can see the bourbon tube here, and so there's linkages in here that link to the bourbon tube. So when the bourbon tube moves, it moves, these linkages will move the needle on the steam gauge. So the water that's in the pigtail or siphon is there to protect the bourbon tube from the destructive force of steam. There's a couple other gauges that are being used in the industry. One is called a compound gauge. A compound gauge shows you both pressure and it will show you vacuum. So if you have a boiler with a compound gauge, you'd be able to tell what the pressure is, and if for some reason the boiler, everything shut down or you were shutting it down, it would tell you if your boiler went into a vacuum. The vacuum on a boiler is a destructive thing. Boilers are built to hold pressure from the inside out, not to have pressure from the outside in. So if you have a vacuum in your boiler, it's a dangerous thing. Another gauge that you commonly find on some boiler systems is just a strict vacuum gauge, and they read out in inches of mercury, and they will tell you if your strainers or filters are getting filled up and need to be cleaned. So your pumps, if they're pulling too hard, it means generally your strainers or filters are getting filled up and need to be cleaned out. So you'll see vacuum gauges also on boilers. And one gauge that you'll see that you'll use all the time when you operate a hot water boiler, and that's the combination gauge. Hot water boilers use a combination gauge. It will have two needles on it. One needle will show the pressure in PSI, and the other needle will show the temperature in degrees Fahrenheit. So for hot water boilers, a combination gauge is used. Okay, so much for the steam gauges. Let's talk about this fella standing back here. This is another boiler fitting, and this is what is commonly called a water column. It's a big cast iron cavity that is attached to the outside of the boiler. The piping on the top goes up, goes over, and goes into the highest part of the steam side on the boiler. The piping going out the bottom goes into the boiler well below the water line. And what does this do for us? The water obviously comes in and travels in through the bottom pipe, and the steam comes in on the top. And it will slow down the fluctuation of the boiling water because there's no heat out here. And this aids the operator in seeing what the water level is in the boiler. If you put a window in the back side of your boiler, you would see the water boiling up and down, heaving inside that boiler. And there's no way that you could get an idea of where the water level is. And it's important that you know that there's water above the top row of tubes in your boiler. You never want to have exposed tubes. So by having this cavity here, it's filled with water, and then over on the side here is what's called a gauge glass. And in the gauge glass you could visibly see the level of the water. So everything about this is slowing down the fluctuation of the water so that you can accurately read it in your gauge glass. Now if your gauge glass were to break, there are 3 valves over on the side. These are called tricock valves. And they're meant to tell the operator manually if there's too much water or not enough water or just the right amount of water in the boiler should this break or become unreliable. How does that operate? Well, your water level should be about in the middle, roughly in the middle of your water column. And if you open the top tricock, you should get steam. If you open the top tricock, you should get steam. And if you get water out of there, you have what's called a high water condition, which means too much water is getting pumped into your boiler for some reason and it's not stopping. The middle valve, you should get both steam and water. So you'll get a mixture at that location. The bottom valve, if you open that, you should always get water. If you do not get water out of that bottom valve, you need to immediately shut off the boiler. So that means a low water condition. The gauge glass periodically also has to be tested. And tested to make sure that it's reliable and everything is working correctly, that there's nothing plugged in the connection on the top and nothing plugged on the connection at the bottom. If your gauge glass fills very slowly, let's say over a period of a day or two, your gauge glass suddenly fills, it starts to fill slowly. That means that the connection at the bottom is plugged and obstructed. And the reason it fills slowly is because it can't get water down here, but because there's steam up here, it starts to condense and slowly the condensate will fill the tube. If all of a sudden you have water filling very fast in the steam gauge, you come by your boiler one time and a half hour later, your gauge is almost full. That is an indication that you're plugged up here. And why is that? Well, if this gets plugged up here, there's no more live steam. And the live steam that was in there reduces its size from 1600 down to 1, so it pulls the water up in very quickly. Now, how do we test this and make it reliable? Well, the first thing we need to do is shut these valves off here on the top and the bottom. Shut them both off and then open the blowdown valve on the bottom. Blow that down so that blows this nice and clean through here. Then once that's accomplished, we open up the top valve. And when you open up the top valve, steam should discharge through there, meaning that this is free and clear up here. If it isn't, it needs to be repaired. Then we go ahead and we close this and open the bottom. And when we open the bottom, we should get a free discharge of boiler water out of that. If there's no discharge there, we got a problem. We need to get that remedied as well. So then you close this all up, okay? You close the top, close the bottom, and then you close your bottom blowdown valve on that. Then the thing to do is to open up your steam valve very slowly, let it warm up your gauge glass. And once you get that opened all the way, then you open up the bottom valve and the water should return promptly in the gauge glass. There should be no slow hesitation. It should return promptly. Now when you're operating a boiler, you can stand there and watch the level of the water in the gauge glass, and ever so slowly it will go down as the boiler boils and uses the water, and then the pump kicks in and feeds the boiler with water, and then the water level will return and go up. And so there will be a slow fluctuation in the water level during the operation of the boiler, and that's very common and nothing wrong with that. Up here is a cross tee on this here piping system. There'll be cross tees at the top, there'll be cross tees at the bottom where it goes into the boiler. You're able to open this up and open up the bottom so you can clean this out. You can open the cross tee at the top and clean it out this way, and the same thing at the bottom. The boiler inspectors come around maybe once a year. They want to see those open. They'll put their flashlights in there and make absolutely sure that the piping on this is free and clear. It's very important that you see and understand the water level in the boiler. The first thing I would recommend when you take over a shift or if you come to work in the morning is to go to your boiler room and check the level and make sure it's reliable. Very, very important. Okay, so that, in addition to the safety valve, very, very important fittings that are on the boiler. There's a couple things that I'd like to talk about as far as the different valves that you'll see on a boiler. One of the most important valves on a boiler is what's called a blowdown valve. The piping will go to the very bottom. It'll be attached to the very bottom of the boiler. One of the reasons for that is so that the sludge and sediment that gathers in the water as the water is being boiled off and new water brought in from the outside, that sludge and sediment has a chance to settle out of the water down to the bottom of the boiler. And so a minimum of once a day, perhaps once a shift, you want to do a bottom blowdown. Okay, so you take your bottom blowdown valve, and on some larger boilers there's two of them. One closest to the boiler is called a fast opening valve. You can open that quickly. It seals nice and tightly, but it is not meant to be the valve that takes the wear and tear as the water rushes out the bottom of the boiler when things get opened up. So you'd open up your fast opening valve first, then you open up the second valve, which should be, in bigger boilers anyway, would be called a slow opening valve. And a slow opening valve has to have a minimum of 5 complete turns of the valve stem before it's completely open. It's meant to open slow so that we get the water on the bottom of the boiler moving toward the blowdown hole and discharge that sediment. When you do a bottom blowdown, I would do it when the boiler is in very low fire or when the unit is shut off. If you can afford to do it, I would recommend perhaps you shut your boiler switch off, shut it off, or when the boiler shuts down, shut it off, and do it in that manner while everything is settled down. Whenever you do a bottom blowdown, You want to make sure that you don't discharge so much water that you lose sight of the water in the gauge glass. There should always be water in the gauge glass. If you lose sight of the water in the gauge glass, that means you have the danger of exposing the tubes inside your boiler, and you do not want to do that. So that's the bottom blowdown. That's one of the things, and that's for getting rid of sediment and sludge. The other thing that a bottom blowdown can do for you is if you have high water in the boiler, if you get too much water, you gotta have some way to get rid of that. A bottom blowdown valve would assist you in lowering the water so that if your water is way up here, you could reduce the amount of water and get it back to the normal operating working level. If that happens and you need to do that, you need to figure out also why that happened and get that fixed. The other thing a bottom blowdown, you can do it to get rid of excessive chemicals or the wrong combination of chemicals in the boiler. So the bottom blowdown valve can be used for that. The other reason for a bottom blowdown is if you completely want to empty your boiler. So if you're taking your boiler out of service, you're going to do some work on it, or you're just cleaning it up for the inspection in the summer, whatever, your bottom blowdown is the valve that would do that. A couple other common valves that you see, especially on a steam boiler, would be your surface blowdown valve. The surface blowdown valve would be right up at the water level on the boiler. And you would open that up periodically to get rid of any kind of oils on the surface of the water or any kind of chemicals, anything that is floating and it is causing an obstruction of the steam boiling out of the water. So if you get too much obstruction and surface tension in your steam boiler, your water will heave and push water along with the steam up in your steam lines and cause water hammer, and that can be a dangerous thing. Okay, so surface blowdowns are widely used. It helps with the balancing out the boiler chemistry of the water and getting rid of impurities on the surface of the water. Another valve you'll see on steam boilers would be maybe halfway down or 2/3 of the way down on the boiler, and it would be called a continuous valve. They are throttling valves, maybe a needle valve or even a globe valve that would be opened, and a certain amount of boiler water would be discharged on a continuous basis, and that is used to balance out the chemical mixture inside of the boiler. Well, let's see, at least probably once a year we need to completely empty our boilers, and we need to clean them and have them inspected. Maybe you have to do it because of needed repair, but anyway, when you need to dump a boiler and you shut it off, and maybe you got the main steam stop valve shut off on it, so everything is contained in the boiler. As you cool that boiler, you got to be right there. You never shut off a boiler and walk away from it in a situation like that, because the steam pressure will drop down and it'll go into a vacuum, and it'll crush your boiler. The atmospheric pressure will crush it and destroy it. So you need to be right there, and you need to watch your steam gauge, and when that steam gauge gets down to about 3 psi, you need to open what's called a vent. There's different styles. Some of them are just a simple small ball valve on a pipe, and you open that up. And when you open that up at maybe 2 to 3 psi, steam will begin to discharge out of it. And there's nothing wrong with that. You want that to happen. And you leave it like that until everything gets down to 0 and not so much as being discharged. Then you open that vent valve completely open, so that as the water cools in the boiler and the water shrinks inside of the boiler and your steam shrinks inside the boiler, air can get inside of the boiler so that it doesn't collapse itself from atmospheric pressure. So if you're going to dump your boiler, you can never do it when it's hot. You never want to shut off a boiler and decide, well, this afternoon I'll shut it off in the morning, this afternoon I'll dump it, because the water is way too hot. The water needs to be cool, almost room temperature. So what I would always do with my steam boiler, I would shut the thing down like on a Thursday, Friday, and I would let it cool over the weekend, let it cool all the next week and the following weekend, and then that following week would be scheduled to dumping the boiler and cleaning it. Whenever you dump the boiler, make sure you're ready to clean it. So you have your hoses or whatever, your water, and you open it up, and as the water is being discharged out of the boiler, you begin to wash the tubes down and clean it as you go. You don't want the mud and sediment to dry onto the tubes or dry onto the sides and bottom of the boiler. Now, on the sides of the boiler, sometimes on the very top and sometimes on the very bottom, there will be what's called hand holes. Those hand holes can be used as a means to clean the tubes and so forth, but they are also there to inspect the tubes, inspect the drum of the boiler, see if there's any pitting or corrosion going on, taking a look at the tubes so that you can see if there's any excessive scale buildup on them and so forth. So hand holes are very important. If I'm dumping a boiler, I make sure that when I take the hand holes out, I have good gaskets on hand to replace those if any of them look like they have any kind of damage. Last thing you want to do is get it all put back together, all your water in it, and all the pressure back on it, only to find out that you got a leaky gasket. So I recommend having those on hand, and if your budget can afford it, just put new ones on every year. They are not all expensive. Well, let's talk a little bit about how the boilers, steam boilers, how they are controlled. The main way they are controlled is through this device here called a pressure troll. This pressure troll has a couple different settings on it. One would be the cut-in setting. So if you want your boiler to have nothing less than, say, 4 psi, the cut-in would be 4 psi. If you want it to cut out at 7, you would put the differential at 4. So once it got to 7, it would shut off. Once it came down to 4 psi, it would turn on again, and then it would go back up to the differential 4 to 7, and it would alternate between those two pressure settings. So this is a pressure troll, and these two also have like a siphon or a pigtail on them, and that has water in it, and it protects the internal mechanism of the pressure troll. In addition to the pressure troll is another control that once the pressure troll brings the boiler on and gets it up and it's operating, it hands it over to the modulating control. The modulating control will modulate the burner, and it sets the firing rate of the burner. So the modulating control will modulate back and forth. And then you have what's called the high limit control. Some of the high limit controls that are out there, they look kind of like, they look like a pressure troll sometimes, and they'll have a setting on it, and then you can test them by turning the set screw down so that the high limit goes below the setting, operating setting on the boiler, and would shut it off. So that's one way you test the test the high limit control. But the high limit control should always be set above the highest operating range of the boiler. You want your boilers to operate in your operating range. You want them shutting off in low fire. You do not want them to get up toward the high end of the operating range and have your high limit control set so low that this shuts the boiler off in high fire. So make sure of that. If you test your high limit control and your highest pressure on your boiler is 7 or 8, then I would set that at maybe 10 or 11 psi. So it's above your operating range. And yet it has to be below the 15 psi rating on your safety valve. On hot water boilers, the controls on the side are called aquastats. So they sense the temperature of the water. Pressure controls on steam boilers sense the steam pressure only. On hot water boilers, the aquastat turns the boiler on and off based on the temperature of the water inside the boiler. They also have high limit switches on them. So if you test the high limit switch on a hot water boiler, make sure that you return it to a setting above the high operating capacity on your aquastat. So, well, we've talked about pressure controls now. There is one other fitting that was pretty common years ago. It was widely used, especially on coal boilers. And that's what's called a fusible plug. A fusible plug is a threaded little plug, and it was probably 1.25 inches long or so. And in the center there was a hole drilled, and it was filled with nickel and tin. And that material in the middle was made and designed to melt out if the water level in your boiler got too low. Then the steam and the heat from the steam would melt that, because that's hotter than the water, and would melt that out. And once that melted out, that fusible plug would push steam out, and it would cause a very loud, shrill whistle, continuous, that would alert the operator to the fact that the water level in the boiler was getting too low. So fusible plugs, there's still some of them out in the industry today. So that's what they're designed for. Well, that's about it for session 2. I hope you've picked up a few things. I hope that you've had a chance to read and study the study guide on chapter 2 in the book, and then have this video in addition to that to help you understand what you've been reading and studying. Get into your boiler rooms, ask questions. If you see something on your boiler or in your boiler room, you don't understand what it is, ask somebody that knows. Nothing's there by accident. And the more you know, the better it is for you as far as safe boiler operating. So if you haven't purchased those books, make sure you get Low Pressure Boilers by American Technical Publishers. In addition to that, purchase the Low Pressure Study Guide by American Technical Publishers. This goes along with the textbook. Very, very important for you. If you're in Minnesota, you've never run a boiler before, and you're getting the entry-level license for special engineers, this is the book you want to get. Safe Boiler Operation Fundamentals, Special Engineer's Guide for the state of Minnesota. It's just a great resource. So with that, I'll say happy boiler operation, guys. Read chapter 3 in the book, and then when you bring up session 3, you will be all prepared for it. Thank you for watching.